This video is about how to solve equations that have an x squared in them. I think you'll find it's really pretty easy. It's just like solving for x, except that we'll be taking some square roots as part of that process. So first thing you will want to know is that squaring and taking a square root are inverse operations. That means that they undo each other, like adding and subtracting undo each other, or multiplying and dividing undo each other. If you add 5 to something and then subtract 5 from that thing, you end up back where you started from. And squaring and taking the square root, do the same thing. So if you have a 5 and you square it, you end up at 25. If you take the square root of 25, you're going to end up right back at the 5 you began with. When you take a square root, there are actually two solutions. What do I mean by that? Well, if you take the square root of 25, you're asking yourself, what number times itself would give me 25? And, well, you probably are saying, well, of course, it's 5. I know that. But there's actually another number you could multiply times itself and get 25. If you want to pause this video and try to guess, go ahead and do so. If you're ready to find out or to check your guess, it would be a -5. Right? A negative times a negative would give me a positive. So -5 times a -5 is also 25. So that means that the square root of 25 does equal 5, but it also equals -5. And there's a very neat shorthand for notating that you mean 5 and -5. You write this little plus over a minus sign, and that just means +5 and -5. Whenever we're solving equations with taking square roots, we always want to consider that there are actually two solutions, and in most cases, write plus or minus whatever that answer is. Let's get into solving some equations. So when solving an equation with a variable that is squared, you're going to start off just like you always do when you're solving a 1 or 2-step equation. You will add or subtract if needed, and then multiply or divide if needed. And you want to do this so that the squared term is isolated. So add or subtract, multiply or divide to isolate the x squared term. In other words, get that x squared term by itself on one side of the equation. So if I'm looking down here for just a minute, in this first example, x squared plus 4, I want to get the x squared term all by itself. That means I'd have to subtract 4 from both sides of the equation to do that. If I subtract 4, I'm going to be left with just x squared on the left and a 16 over on the right. So that's what I mean by step 1, add, subtract, multiply, or divide to isolate the x squared term to get it by itself. Next step is going to be to take the square root of both sides of the equation. So take the square root of both sides of the equal sign. And the third step is just to remember positive or negative roots or solutions. So taking the square root of both sides of an equal sign, so square root of x squared equals square root of 16. Square root of x squared is just plain old x, and the square root of 16 is plus or minus 4, and that's my answer. Let's try the next one. X squared minus 5 equals 31. Add 5 to both sides, which leaves me, x squared, not x cubed, x squared on the left equals 36. Take the square root of both sides, and x equals plus or minus 6. Let's change this problem. It'll make it a little nicer, I think. Let's make it 49. This 49. So the equation I'm going to solve is 2x squared minus 1 equals 49. It'll just turn out a little bit more nicely for what we're trying to do here. So I've got two things to move to get that x squared by itself. I want to add the 1 to both sides. So 1 plus 49 gives me 50 on the right, and 2x squared over on the left. And I want to divide out the 2. So divide both sides by 2, which will give me x squared equals 25. Once you're at this step, take the square root of both sides, and x equals plus or minus 5. If you want to pause the video for a minute, take another look at those 3 problems or the notes, please do so. And then hit play again when you're ready to resume. Alrighty, last 3 problems. I'm going to have you try this one on your own, and try this one on your own, and we're going to take a look at this last problem. 3x squared plus 6 equals negative 12. So I'm going to start off just like I have been. Subtract 6 and subtract 6. I'll have 3x squared equals negative 12 minus 6 equals a negative 18. Looks so good so far, right? So let's see, divide both sides by 3. X squared equals negative 6. All right, you may already see the problem with this problem. If not, let's just keep going and maybe you'll figure out why I'm concerned. Take the square root on both sides. Square root of x squared is just x, but then look at the right. I have a complex number here. Complex number because there's a negative under the square root sign. And in the context of geometry, we don't have any tools for dealing with square roots. So we are going to have to stop here and say that x equals no real number, or no real number exists. Now usually what will happen in this class in geometry, because we're measuring things, you will run into negative square roots or negative radicands only if you have made a mistake. You shouldn't be running into negative radicands really at all. So if you get a negative under a radical sign, what that means is you probably have made a mistake and you need to go back and check your algebra.